Hello children, welcome to Zero Panic Maths. In today's session, we are going to start with a new chapter, Chapter 4, Quadratic Equations. Okay, now in this year only, in Chapter 2, if you remember, Chapter 2 Polynomials, if you remember, we have studied what exactly is a quadratic polynomial. Okay, a polynomial of degree 2 is called as a quadratic polynomial, and it was of the form ax square plus bx plus c, where a is not equal to 0. Such an expression satisfying this form was called as a quadratic polynomial. Okay, now when we equate such a polynomial to 0, then we get a quadratic equation. It means that if you just write an equation or a quadratic polynomial and equate that to 0, this itself is called as a quadratic equation. Okay, polynomial without equating to 0, and equation if you equate that to 0. Okay, now let us, this is what, just a simple definition of what exactly is a quadratic equation. Okay, so we will see some examples in the discussion. Okay, now let us have an example in real life. What exactly a real life situation might arise where we get a quadratic equation to be solved to get the solution for the problem. Okay, now have the real life example. Now suppose there is a prayer hall. Let us read this. Suppose a prayer hall's carpet area of 300 square meters. Okay, and with its length 1 meter more than the twice of its breadth. Okay, let us just depict that first, so that it will be easy for us to understand it. Okay, so it is a rectangular carpet area, because they have given the area in terms of square meters, so it will be a rectangle. Assume that it will be a rectangle. Okay, and assume that this is its breadth and this is its length, right? This is the breadth and this is the length. Now what they have given, first of all, they have given that the rectangular area is 300 square meters. So breadth into length is equal to 300 square meters. That is what is given. Okay, then what exactly they are telling is the length of this area or the rectangular carpet area is one more than, read that carefully, one more than, it means plus one, twice of its breadth, twice of its breadth. So let us suppose, if I consider x as its breadth, what will be twice of its breadth is 2x, and what they are saying, one more than twice of its breadth. So what exactly is that? Length is 2x plus 1. Assuming, okay, let us assume that breadth of this rectangle is x, then with the given statement, it makes the length of this rectangle as twice of its breadth plus 1, that is 1 meter more than twice of its breadth. I hope you understood this concept. Okay, then how can I convert this given data into a quadratic equation? Now, since they have given that the area is 300 square meter, breadth into length will actually give us the area of the rectangle, right? So suppose breadth of the hall is x meters and its length should be 2x plus 1 meters, then breadth into length is x, that is breadth, and multiplied by 2x plus 1, which is length. This is breadth and this is length, which is area. And what is the area they have given is 300 square meters. If you solve this and get a quadratic equation, that will become an equation that depicts this situation. Okay, we will only form the equation, we will not solve it. Okay, let us do that. X into 2x, what it will be? It will be 2x square plus x into 1, it is x, and 300 you take it to the left side will give us minus 300. And what this equation? This equation is of the form ax square, where a is 2, okay, plus bx, where b is 1, which is coefficient of x, right, plus c, where c is equal to minus 300. So it exactly represents the standard form of the quadratic equation. So this is how you depict the real world problem into a quadratic equation, right? Okay, now let us see what additional information they've given. So with whatever we have studied here, whatever example we have seen, we can say that a quadratic equation in the variable x is an equation of the form, okay, so this is not ax2, it is actually ax square, okay, so it is actually wrongly typed here. It is of the form ax plus b is equal to 0, where a, b, c are real numbers and a is not equal to 0 is the standard form of the quadratic equation. That is the standard form of the quadratic equation. You might be actually remembering what it is exactly equal to the quadratic polynomial. Okay, so there is no difference at all. The polynomial without equating it to 0 is called as a polynomial. If you equate that, it will become a quadratic equation. That is the standard form. Okay, so any equation of the form p of x is equal to 0. So they are saying that in general, in any equation of the form p of x is equal to 0, where p of x is a polynomial of degree 2. Okay, it should be a polynomial, but it should be of degree 2. That's when it is called as a quadratic. Quadratic means, you know that quadrate, the word quadrate means square or of the power 2. Okay, it is a quadratic equation. So any example we can take as a quadratic equation example that we have just seen. Okay, this is one example, is an example of a quadratic equation. Or else you can say 2x square plus 3x minus 1 is also equal to one of the quadratic equation. Or else you can even write something like this: 10 minus x square plus 3x, right? So this is also a quadratic equation only, and it is given in the form of, it is ax square plus bx plus c. It is in the form of a standard form of quadratic equation only. So any example with or any polynomial p of x is equal to 0 is called as a quadratic equation when it is of degree 2. So this is what you need to remember, right? Okay, now let us see some of the solved examples and analyze the situation and form the quadratic equations. We are going to only form the quadratic equations. Okay, we are not exactly going to solve it. Okay, solve it to get the values of it. Okay, now let us read that. John and Jivanti together have 45 marbles. Read it carefully. Okay, 45 marbles. Both of them lost 5 marbles each. Okay, first of all, they had together they had 45 marbles and they lost 5 marbles. There are two situations given. Okay, and what exactly is given again? Product of the number of marbles they now have is 124. Now have means after losing 5 marbles each, they have the product after losing 5 marbles each will become 24. I will actually depict this into the equation format and you will easily understand that. So what exactly is asked again? We would like to find out how many marbles they had to start with, how many marbles they had initially, so that this situation is satisfying that. Okay, okay, now let us assume, let uh, John had, okay, or we can say let number of marbles with John is equal to x. I can say John had x marbles. Okay, so if John had x marbles, then how much Jivanti will have? How much Jivanti will have? she will have 45 minus x, because they are saying both together had 45 marbles. So you cannot consider here as Jivanti had y marbles, okay, because this is not a linear equation with two variables. It is a quadratic equation with one variable, okay. So in that format only you need to write, or else you can easily do that also. So suppose I will just give a simple example, okay. One minute I'll take, okay. Let John had x marbles and say Jivanti had y marbles. So both together had 45 marbles, right? 45 marbles, right? Let us make it easy. So now what is y according to this? It is 45 minus x, right? It is 45 minus x. And what is y we are considering? It is the number of marbles Jivanti had. Okay, so we can directly say that instead of saying y, we can directly say if John had x marbles, then Jivanti will have 45 minus x marbles according to this statement. You understood this now clearly? Okay, now let us write that only. Instead of writing it as y, number of marbles with Jivanti, I can say Jivanti is 45 minus x, right? X with John, 45 minus x with Jivanti. Okay, now both of them lost 5 marbles. After losing 5 marbles, I will write with the given after losing 5 marbles each, right? Each of them lost 5 marbles. Okay, so after 5 marbles, what will be John, what will be the marbles with John? It is x minus 5, right? And what will be the marbles with Jivanti? It is 45 minus x minus 5. Okay, let us write that only. 45 minus x minus 5. I'm just subtracting 5 from each of the marbles. Okay, and what they are saying that after losing 5 marbles each, the product of the numbers of marbles they now have 5 minus x minus 5 and 45 minus x minus 5. The product of that is equal to 124. This is what they are saying. Hope you understood this. Okay, okay, now let us resolve this. What happens here is x minus 5, and then 45 minus 5 is actually 40 minus x is equal to 124. I can say bring 124 to the left side to make it minus 124. Okay, now x into this one and minus 5 into this one. Let me first multiply x with 40 minus x. Okay, x with 40 will give me 40x. X into minus x will give me x square. Minus 5 into 40 will actually give me minus 200, right? Minus 5 into minus x will give me plus 5x, and minus 124 is equal to 0. Okay, now what else? Okay, let me write x square term first. Minus x square, minus x square. 40x plus 5x is plus 45x, or okay, okay, we don't have any other x terms. Okay, minus 200 minus 124 is minus 324 is equal to 0. So this is what exactly the quadratic equation, but let us keep the x square term as plus. So multiply throughout by minus. So that will give me minus into minus plus, and minus into plus minus. So in place of minus a plus will come, and in place of plus minus will come. Okay, this is minus and this is plus. Plus 324 is equal to 0. So this is what the depiction of this example. What exactly is that? X square minus 45x plus 324 is the depiction of this. Okay, let us see the next example. Okay, so the next example, it says a cottage industry produces a certain number of toys in a day. Okay, read the question carefully. an industry produces a certain number of toys in a day. Okay, the cost of production of each toy, which is in rupees, was found to be 55 minus number of toys produced in a day. Okay, now let us underline this statement because this might give us some information related to equation. Okay, 55 minus number of toys produced in a day. So we can consider number of toys produced in a day itself as x, so that the uh, production cost, the cost of production of each toy will become 55 minus x. That will be the way to solve it. Okay, on a particular day the total cost of production was 750 rupees. Okay, cost of production they have given it as 750 rupees. Okay, and they have asked, we would like to find out the number of toys produced on that day. Okay, now we are not exactly going to find out the number of toys. Okay, that is solving that equation, but we are actually depicting this situation into a quadratic equation. Okay, now let us start with number of toys produced in a day. Okay, number of toys produced in a day. Okay, listen carefully. Okay, let number of toys produced on that day, or on that day what they have given as production cost was 750 rupees. We will consider that only. Okay, number of toys produced on that day is equal to x. Let us assume that the number of toys produced is equal to x, and what they have given, if x toys are produced, then the cost of production of each toy was found to be 55 minus the number of toys produced, right? Number of toys produced we considered as x, so cost of production of each toy will be 55 minus x, because that is what is given here. Read that carefully. Okay, and cost of production of of each toy they are saying, right, of each toy is 55 minus x, right? This is the total number of toys produced, and this is the cost of each toy to be produced. So if we multiply both, that will give us the total cost of production, right? So this is the total number of toys produced, and this is the cost that will be there for one toy to be produced. So x into 55 minus x is actually the total cost of production. Okay, therefore total cost of production, see, total cost of production, total cost of production is equal to x into 55 minus x, and that is equal to what they have given, 750. That is equal to 750. Solve this question to get a quadratic equation. Okay, so it is 55x minus x into x is x square and minus 750 is equal to 0. 750 I have taken to the left side. Again I can multiply this by minus and take the plus x square, plus first x square term plus 55x minus 750 is equal to 0, and multiply by minus throughout to get the final expression, that is 55 minus x plus 750. Hope you understood this. So this is what our equation to be resolved to get the final answer. What is that? We would like to find out the number of toys to be produced on that day. So this is the equation that depicts this situation, and if you solve this equation we will get the exact answer. Okay, we are actually going to solve these questions in exercise problems, but here in example we are actually just depicting them into the quadratic equation format. Okay, let us see some more examples. Example 2. Okay, now example 2, we are actually resolving the given equations and finding out whether the given equations are quadratic or not. And how are we going to decide that whether it is a quadratic equation or not? If it is in the form of ax square plus bx plus c is equal to 0. If you get an equation after resolving these given equations, if you get an equation of that standard form, then we are going to say it is a quadratic equation or not. Okay, let us resolve this. Okay, now how do we resolve this? It is actually an algebraic formula, a minus b whole square. Okay, now if you remember, I will just write that a minus b whole square. Okay, hope you remember this. A minus b whole square is a square minus 2ab plus b square, right? We are going to use this a square minus 2ab plus b square. Okay, let me write this here. We are going to use this formula to resolve this part, and plus 1 we are going to keep it as it is, and finally we are actually resolving the equation. Okay, now in place of a it is x square, right? X, so a square minus 2ab, 2a is x and b is 2, right? According to this, plus b square, that is 2 square plus 1 is equal to 2x minus 3, is equal to 2x minus 3. Okay, let us resolve this again. Okay, x square minus 2 into 2, 4, that is 4x, right? Plus 2 square is 4 plus 1, right? That is 5. Take 2x to this side, that is minus 2x, right? And minus 3 taking to the left side will become plus 3, and it will become equal to 0. Okay, now minus 4 minus 2x, x square minus 6x, okay, and 5 plus 3 is 8. Now tell me whether it is a quadratic equation or not. It is a quadratic equation because is of the form ax square plus bx plus c is equal to 0. Therefore it is a quadratic equation. You need to write this at the end. It is a quadratic equation. Done. So this much only we have to prove that it is a quadratic equation. Okay, let us quickly see the next example. Okay, now there is something else given again. Okay, we'll have to solve the right side part. Observe this right side part. What algebraic formula you will remember by looking into it? It is a plus b and a minus b. What is a plus b, a minus b? A square minus b square, right? So I'll write that also. A square minus b square is equal to a plus b, where a is x and b is 2, and it is a minus b. Okay, remember this formula? Remember this formula? Okay, let us resolve that right side by using this formula. Okay, and left side as it is. X into x, x square, left side. X into 1 is x plus 8. We're keeping as it is, right? Now directly apply, because the right side is of the form a plus b and a minus b. You can directly say a square minus b square, where a is x and b is 2, right? So I can say x square minus 2 square is 4, right? It is a square minus b square that I have written at the right hand side. Okay, now let us take the right side item to the left side. X square minus x plus 8 minus x square plus 4, minus 4 taking to the left side, plus x square minus x square. So here if you observe carefully, the x square term will get cancelled because it is plus x square and minus x square, and what remains here is x plus 8 plus 4, which is 12. So is it of the form ax square plus bx plus c is equal to 0? No, it is of the form ax plus b is equal to 0. You can call it as a linear equation, okay, because it is of the form ax plus b. So is not of the form, not of the form ax square plus bx plus c is equal to 0. Therefore, it is not a quadratic equation. It is not a quadratic equation. You can say that. It is not a quadratic equation. Simple, right? Okay, let us move quickly to the next problem. Let's see what this equation will become. Okay, x into 2x square. Okay, there is no standard form that I can use it to resolve it, so you can go by the usual method. X into 2x is 2x square, right? X into 3, it is 3x, and x square, you take it to the left side, will become minus x square, and minus 1 is equal to 0. So it is 2x square minus x is 1x square plus 3x minus 1. See, so simple it is. Okay, it is already in the form of ax square plus bx plus c, where c is minus 1, b is 3, and a is equal to 1. All are real numbers. So therefore it is a, you can write that is of the form, all that you can write. It is a quadratic equation. It is a quadratic equation. That's all. Okay, simple solution we got. Okay, now let us quickly move to the next problem. Okay, next problem is little bit different than the previous problems. Okay, here if you see, you have x plus 2 whole cube is equal to x cube minus 4. So at the first look, you might say that because we have a x cube term here, it might not be a quadratic equation, but you should not decide based on that. You have to solve that equation finally, and the final answer, if you get the power of 2 as the highest power of x, then only you should decide. Based on that you should decide. Okay, now before that, you should be knowing what exactly is a plus b whole cube. There is a algebraic formula for that also, a plus b whole cube. Okay, that is a cube plus 3ab square plus 3a square b plus b cube. Okay, there is a formula, but we can do it with a usual way only, and then we will see whether it satisfies or not the condition of standard quadratic equation. Okay, now let me write, since it is consider x plus 2 as one term, a cube. Okay, let us consider this as a, then it will become a cube, right? A cube, can I write a into a square? A into a square. So in that way, what I am doing is x plus 2 whole cube, I am writing x plus 2 as one term and x plus 2 whole square as another term. See, x plus 2 with 1 power 1 and with power 2. It will give me x plus 2 to the power of 3. That is whole cube. Okay, I've just splitted that power, and is equal to x cube minus 4. Hope you understood this step. Okay, because I know what is a plus b whole square, I have done this. Okay, instead of applying the a plus b whole cube formula directly. Okay, so let me write this x plus 2 as a plus b whole square, that is a square plus 2ab. 2a is x and b is 2, and b square, that is 2 square, let me write that as 4. Okay, is equal to x cube minus 4. Right, now it is x to the whole term plus 2 to the whole term. Multiplication you should be doing it. Okay, remember this, x multiplied by x square, okay, plus 2 into 2, it is 4x plus 4 plus 2 into the whole term again, right? 2 into x square plus 4x plus 4, okay. Or along with that, I can bring the x cube also to the left side and minus 4 also to the left side to make it minus x cube plus 4. Okay, now let us multiply this. X into x square is x cube plus 4x into x, which is 4x square, x into 4, which is 4x. See, you are going to get multiple x cube, x square and x terms here. Be careful while multiplying. 2 into x square is 2x square. 2 into 4x is 8x. 2 into 4 is plus 8 minus x cube, right? Plus 4. Hope this is all correct. Okay. Now let us cancel if there are any terms with opposite signs. We have the term x cube with opposite term minus x cube and plus x cube got cancelled. So this is the reason that I told, just by looking at the power 3, don't decide that because it might get cancelled later. Okay. So how many terms of x square are there? 4x square plus 2x square, that is 6x square, right? Any other terms with x square? No. Okay. And 4x plus 8x, it is 12x. It is 12x plus 8 plus 4, the constant terms. Anything else? No. Okay. So that is 12 is equal to 0. Okay. Anything common I can take? Okay, you can take the common 6 or divide by 6. You can say divide by 6. That can also be done, right? Divide by 6. To make it simpler again, divide by 6 will actually get me x square, and this is 2x and this is 2 is equal to 0. So it is of the form ax square plus bx plus c is equal to 0. So this is a quadratic equation. You can write that this is a quadratic equation since it is of the form ax square plus bx plus c. Okay. Okay, let me see. Okay, now we came to exercise problems 4.1. So let us stop our discussion here only and let us end the session here, and in the next session we will see the exercise problems 4.1. Okay, thank you.